So good evening, everyone. This is lecture number 1 in wave optics, and we are going to start this chapter. Let us start with this chapter with something that we already know. We already know that. Yes, beta. Are you able to hear me? Able to see me, everyone? Okay. The first thing that we have to understand about this chapter wave optics is we had done the previous chapter and we had done two phenomena in that previous chapter. What were the two phenomena that we studied in the previous chapter? Which two phenomena of light that we studied in the previous chapter? Tell me. Anyone knows it? What are the two phenomena that we studied in the previous chapter? Two phenomena of light that we studied in the previous chapter. Tell me. No one knows what we studied in the previous chapter, beta? Yes, Abhiram, thank God. Reflection and refraction, those are the two phenomena we have studied in the previous chapter. Reflection by plane mirrors, reflection by curved mirrors, refraction by plane surfaces, refraction by curved surfaces, refraction by lenses. Now, you might have heard that light has got dual nature. Now, what do you mean when I say dual nature? Whenever we think about any object or any thing in physics, either we think it as a particle, tuck, 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 tuck. An electron is a particle. I am a particle. This pen is a particle. A bus is a particle. So either we take them as particle in physics. Now, what do we mean when I say particle? They are discrete, one particle. We can count the number of particles, one, two. They can be very large. Molecules of a gas, they are very large, but still they are particles because we can count them. So in physics, whatever we encounter, it may be a particle. Particle are discrete. We can count them. Tongue, 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 tongue. These are particles. Either it's a particle or it's a wave. Now, what's the difference between a particle and a wave? Particles are discrete. Tuck, 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 tuck. But wave is continuous. It does not come like this. It comes continuous. So in physics, either a thing is a particle or the thing is a wave. But light, for that matter, has dual nature. That means it has the nature of both what? A particle as well as a wave. Particle as well as a wave. That means sometimes it may behave as a particle, sometimes it may behave as a wave. Some phenomena that light exhibit can be explained whether we take it as a particle or we take it as a wave. Whether we think of it as a particle, okay, let us think that light is a particle. What all phenomena can be explained? There are a number of phenomena that can be explained by the particle theory of light. Reflection you can explain by particle theory. Refraction you can also explain by particle theory. There are some phenomena which can only be explained by the wave theory of light. Now, reflection and refraction, these are two phenomena of light which can be explained both by the particle theory and by the wave theory. Are you getting my point, bacha? Reflection and refraction, what we did in the previous chapter, they can be explained in any way. Whether you think of light as a particle, you can explain it. Whether you think of light as a wave, you can explain it. But there are some phenomena which can only be explained by the wave theory of light. And that is why the name of this chapter is wave optics, because in this chapter, what we are going to study is those phenomena we are going to study which cannot be explained by the particle theory of light, but they have to be explained by which one? They have to be explained by which one? They have to be explained by which one? Which theory? Some phenomena cannot be explained by the particle theory. So which theory we'll have to apply to explain those phenomena? The wave theory. And what are those phenomena which we can only explain by the wave theory? Any idea? What are those phenomena which can be only explained by the wave theory? These are the phenomena that we are going to study in this chapter, in this class. The first phenomena is superposition, interference, diffraction. These are the phenomena that can only be explained by the wave theory of light, and these are the phenomena that we are going to study in this chapter, in this part. Do we understand this? Yes or no? No or yes? Do we understand this? So these are the things that we are going to study in this chapter. So that is the name of this chapter, and this is known as wave optics. So we are going to study some phenomena which cannot be explained in any other way. We get this? Now, as soon as we think about wave optics, the first thing that comes to our mind is the phenomena of wavefront. Anyone has heard about this term wavefront? Anyone? Anyone heard about this term wavefront? No one?
No, sir.
Okay. You have not heard about this phenomena? Not a problem. Let me try to make you understand what is a wavefront. So we can write the definition first. A wavefront is a locus of all points in the same phase. Now, what do I mean by phase? We will understand this term just now after we undergo or we study some other terms. Remember, this chapter is all about the terms that we are going to study. If we can understand those terms, this chapter is going to be very simple. Wavefront is the locus of all points which are in the same phase. The easiest way to understand phase is we can think it of as a race between two people. If those two people are running together, they are reaching every point together. Every point they will reach together. We will say that these two people, these two particles, they are in the same phase. Do we understand this? Two people running together, they will reach all the points together. We can call that they are in the same phase. Are we getting this? Yes or no? We're getting this?
Yes, sir.
Okay. Now, if one particle or one person is ahead and the other person is behind, we will say that they are not in the same phase, because this gentleman will be reaching everyone everywhere earlier, and this gentleman will be reaching the same points afterwards. So we will say that they are not in the same phase. Do we understand it in simple language? So that is what I mean when I say, what do I say? That the particle are in the same phase or they are in different phases. Do we understand this simple thing? So if we
Yes,
have
sir.
all the points which are in the same phase, which are together, that locus, those all points are known as wavefront. Do we get this? Now, as soon as we talk about wavefronts, there are three types of wavefronts that we are going to encounter. So we will have a look at the three types of wavefronts and then you will draw them. The three types of wavefronts that we are going to encounter are the wavefronts which are, oops, what I have done here, are the wavefronts which are here. The first type of wavefront is known as a spherical wavefront, which is in the shape of a sphere. The spherical wavefront is created by a point source. So a point source, if I have a point source of light, for example, if I take, I'm very far from sun is not a point, sun is a very huge object, but from very far away, the sun might look like a point, or a very distant star might look like a point. The wavefront that that point will create will be spherical. Do we understand this? The wavefront that a point creates or a point source create is spherical. That is the first type of wavefront. If instead of a point source we have a line source, now line source is a tube light that is lighting your room. A tube light is like this. It is a line source. Light is in the form of a line. That line source create cylindrical wavefronts, and if rays are coming parallel to us, those parallel rays of light will create plane wavefronts. Do we understand this? If we have parallel waves of light,
Yes, sir.
they will create plane wavefronts. If we have a line source of light, it will create cylindrical wavefronts. If we have a point source of light, it will create spherical wavefronts. I'll give you 2 minutes to write this.
Done, sir.
Everyone has done this? Yes or
Completed,
no?
sir.
Okay. Now, what you got to remember about this wavefront, you might not get a direct question, you will only get indirect questions here. Do we understand this? We'll only get indirect questions on this. So we'll go through this quickly. Now, there are 2 or 3 important points that you must remember about this, and I'm going to tell you those points. Point number 1 about this wavefront. You can see here, this is the direction of the propagation of wave. When I say propagation of wave, I mean the direction of light rays, in which direction the light rays are going. This
Sir,
direction, yes, beta.
camera off. Sir.
So what? Does it make any difference? My camera is on or off. Okay. The direction of light rays is always perpendicular to your wavefronts. So remember this point. See, here there are light rays and your wavefront is perpendicular to the light rays. Do we understand this, bacha? So this is one
Yes, sir.
important point that you must remember about wavefronts. The direction of light rays or direction in which the light is traveling is always perpendicular to the wavefronts. And you must remember which source creates what types of wavefront. These are the only two things that you must remember about the wavefront. I'll give you a minute to note it down.
Peters.
Everyone
Done, sir.
completed? Okay. Well done. We move ahead in life. Wavefront, types of wavefront we are done. Now, we'll have to deal with something known as superposition, interference, and all these things in this chapter. So we have to understand the basic terms of this chapter. I told you, if you understand those terms, everything else is simple. So the first thing that we are going to see is the equation of a wave. Equation of a particle of a wave. Okay, and that wave is known as a sinusoidal wave. Have you ever heard about the word sinusoidal? Sinusoidal wave is in the form of either a sine wave or a cos wave. A sine wave or a cos wave is known as a sinusoidal wave. Now the most general form of this wave will be in this form. Y is equal to a sine omega t plus phi. This is the most general form of wave that you shall encounter. Have you seen this form of wave anywhere? Have you seen this equation anywhere? Yes or no? No or yes? Have you seen this equation anywhere, bacha? Have you seen this equation?
Yes, sir.
Where? Where have you seen this equation? If you have seen this equation, then half of my job.
Wave equation.
Where, bacha?
Wave equation, sir.
Wave equation, sir. Sorry, I don't understand. This is wave equation. Yes, that is correct. We have seen this equation, right?
Yes, sir.
Okay, that solves my purpose. So now you can tell me, bacha, what do you mean by this y? If you've seen this equation, you can probably help me out. I thought that you might not have seen this equation. Can you tell me, bacha, what is this equation? Or I mean, what is y in this equation, beta?
Displacement.
Y in this equation is displacement of the particle from the mean position. Well done. Very well done. Then can you also tell me, since you know that this is y, can you also tell me what is this A in this equation? A. What is this A? Yes, bacha.
Amplitude.
Amplitude of the wave or amplitude of the particle. What do you mean by amplitude? I hope everyone is writing. What do you mean by amplitude, bacha?
Maximum height.
Maximum height. Okay, not exactly maximum height, but
Of the whole.
it is the
Maximum height of the wave, sir.
maximum height of the wave. Okay, not maximum height of the wave, maximum displacement of the wave. Here we have displacement, so on the other side we also have displacement. Do we understand this?
Yes,
Yes
sir.
or no? No, yes. What is happening here?
Yes, sir.
Okay, do we understand this? So amplitude is maximum displacement of the particle from the mean position. You can write it as maximum displacement of the particle is known as your amplitude. Maximum displacement of the particle is your amplitude. Well done. What is T?
Time.
T is time. Everyone understands this? T is time?
Yes, sir.
Okay. What is this omega here? We've understood T is time. Well done. What is this omega here?
Don't know, sir.
Okay. Omega is known as angular frequency. Have you heard the term angular frequency? Bacha? Angular frequency. Yes or no? Angular frequency, any idea? Anyone? Okay, you might not have heard about this. Let us go back. Have you heard about time period of a wave or time period of oscillation or wherever? Have you heard about the word time period denoted by capital T?
Yes, sir.
What do you mean by time period? Time taken to complete? Time taken to complete what, bacha? One revolution, yes or no? Or one oscillation, yes or no?
Yes, sir.
If you have heard time period, you would have also heard F, which is known as frequency.
Yes, sir.
What do you mean by frequency? What do you mean by frequency? Tell me, bacha.
Half of the time.
Half of the return? Sorry?
Don't know, sir.
Frequency is the inverse of time period. Have you seen this? 1 by T. Frequency is 1 by T.
Yes,
That's how you
sir.
see it. It is the time taken to complete one revolution. Number of revolutions in 1 second is the inverse of this. Number of revolutions in 1 second. That is known as the frequency. Do we understand it now?
Yes, sir.
Omega is 2 pi multiplied by f, or it is equal to 2 pi divided by t. This is the angle turned. Some people also call it angular velocity. Angle turned in 1 second. That is angular frequency omega, my dear friends. Now, I hope you will remember it now. Yes or no? No, yes.
Yes, sir.
Angular frequency is the angle that it turns in 1 second. Frequency is the number of revolutions in 1 second. Do we understand this? Everyone, I'll give you 1 minute.
Yes, sir.
Note it down. Note it down.
Completed, sir.
So fast. What about everyone has done this? Everyone? Shall I move ahead, beta?
Yes, sir.
Okay, great. We are not done still. There are some more things left here. What is this phi known as? You might not know this. This phi is an angle, and this is known as initial phase, or we also call it EPO, EPOCH, initial phase. Phase. Mark this word phase. This word phase also came in wavefront. Now look at this entire yellow thing. This entire yellow thing is a sine of something. Sine of omega t plus phi. Sine of something. The sine of something, this something has to be an angle. Yes or no, my dear friends?
Yes, sir.
This entire thing, this entire yellow thing, which is an angle, this is known as the face of the particle. This is known as the face of the particle, and this is basically telling us what? It is telling us, depending on this angle, which may depend on time, where the particle is. If you put the value of time as 0, omega t becomes 0. The particle is y is equal to a sine phi. Phi tells us where the particle is. If you put t ka value as 1, omega into 1, omega plus phi. Sine of omega plus phi will tell you the position of the particle. If you put t as 2, 2 omega plus phi will tell you the position of the particle. This phase tells us where the particle is. And this entire thing is known as the phase of the particle. Do we understand this? Yes or no? No, yes.
Yes, sir.
So this entire thing is known as the phase of the particle. If two particles have the same phase, beta, then what will happen? If two particles have the same phase, then what will happen? They will always be together. Do we understand this? Yes or no? If they have the same phase, they will be together. They will do everything together. We got this? Yes or no? No, yes. That is what we say, particle in the same phase. When particles are in the same phase, they will do everything together because they are together. Anyone understands this? Yes or no? No, yes.
Yes, sir.
That is what I say, particle in same phase. Anyone understands this? Now, when particles are in different phase, they will not be together, and someone will do it first and someone will do it later on. Do we understand this?
Yes, sir.
Everyone understands this? Okay, then we move ahead and understand the meaning of phase and phase difference. So let us now write two equations. Let me write the first equation as y is equal to, okay, you can't see me, probably. Okay, you can see it now. Let us write the first equation as y1 is equal to a1 sine omega t, and let us write the second equation as a2 sine of omega t plus phi. Now something has been written similar and something has been written differently knowingly in this. Can you point out what thing in both the equations I have written similar and what thing I have made different in the two equations? You can easily see which things are kept same knowingly and which things are changed knowingly because we have to do something with this. Yes, tell me, my dear friends, which terms are similar, same, and which terms have been changed. If you look, omega, which is the angular frequency or time period, they have been kept same. Yes or no? No, yes.
Yes, sir.
But we have changed the amplitudes. Yes or no? We have
Yes, sir.
also changed this yellow thing. This entire yellow thing is the phase of this wave. Yes or no? This entire yellow is the phase of this wave, and this entire yellow thing is the phase of this wave. Now I ask you, let me call this phase as phi1. Phi stands for phase actually, and let me call this phase as phi2. Now let me ask you this question, and if you can answer this, that means you've understood this concept. Are these two particles, are these two waves in the same phase, or are they in different phase? Are these two particles, these two waves, are they in the same phase, or are they in different phases? Do they have the same phase, or are they having different phases? Yes.
Different phase.
Different phases. The difference in the two phases, let me call it as delta phi. Phi2 minus phi1, if I find out, that will come as phi. This phi is known as the phase difference between the two waves. This phi is known as the phase difference between the two particles. Do we understand this, bacha?
Yes, sir.
This phi is known as the phase difference between these two particles or these two waves. That means they are not together. They are not doing everything together. Y1 is doing something at some time. At the same time, Y2 is doing some other thing. It is not, they are not together. Do we understand this? Now,
Yes, sir.
they are not together. Someone is ahead, leading, and someone is behind, lagging. Someone is ahead, leading, someone is behind, lagging. Who is leading and who is lagging? Can you tell me? Who is leading? Who is lagging? Who is ahead, leading, and who is behind, lagging?
One lagging, sir.
Y1 is lagging or Y2 is leading. So I can write it like this: Y2 is ahead. Y2 is ahead or leading Y1 by a phase angle of phi. Do we understand what I have written here?
Yes, sir.
Y2 is leading Y1 by a phase angle of phi, or I can write the same thing in a different way. Y1 is lagging Y2 by a phase angle of phi. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye, bye bye, bye bye? I'm going. Have you understood this, bacha?
Yes, sir.
I give you 2 minutes to note this down. Please note it down.
Completed, sir.
Everyone? Okay then. We move ahead. Now we have to understand three terms that are going to trouble us in this entire chapter. And those three terms are phase difference, path difference, and time difference. Phase difference, path difference, and time difference. Phase difference is denoted by delta phi. We have already seen it. Delta means difference or change. Phi means phase. Path difference is delta x. Time difference is delta t. Now, what do we understand by these terms? Phase difference, path difference, and all of these. So I'll try to make sense, and let us see that I make sense. And let me draw this. Oops, I always do it wrongly. I don't know why. Why I can't draw it straight. Yes, now it is okay. Okay, so now let me draw a wave. And I don't know whether you understand this. This is a sine wave. Do you understand a sine wave? Have you seen a sine wave? Yes or no, bacha? This is a sine wave.
Yes, sir.
Okay, now let us write all the terms that we have seen up till now. Now this is the equation of a sine wave. So the equation will go like this. Y is equal to A sine omega t. This definitely is your time, and here I have plotted y. Yes or no? We understand this? Okay.
Yes, sir.
This is the maximum distance it goes up. So this is known as what? You already told me that.
Yeah.
This is known as the amplitude A. This is known as the amplitude A, maximum displacement. Yes or no?
Yes, sir.
Okay. Now, in terms of time, if I talk about, if the time starts from 0 here, time taken to complete one oscillation, and this is the one complete wave, sine wave. So here the time would be capital T, time taken to complete one oscillation. Yes or no, my dear friends?
Yes, sir.
So in between it will be T by 2. Yes or no? Here the time will be T by 4, and here the time will be 3T by 4. All of us understand this? Yes or no? You understand this? Okay, if I write the same thing in terms of wavelength, here it is 0, and here at this point one wave is complete, so the total length will be wavelength lambda. Yes or no, bacha? At this point,
Yes, sir.
okay, so at this point it will be lambda by 2. We understand this? At this point, in terms of distance, it will be lambda by 4, and at this point it will be equal to 3 lambda by 4. All of us understand this? The red ones
Yes, sir.
are plotted in terms of time. The green one are plotted in terms of lambda distances. Let me go to the purple one. In terms of angle, when I talk about one revolution, how much angle it covers in one revolution? 2 pi. Yes or no? 2 pi is 360 degrees. So in terms of angle, here the angle is 0, and at the end the angle will be 2 pi. Yes or no? Here in
Yes, sir.
between the angle would be pi. Here the angle would be pi by 2, and here the angle would be 3 pi by 2. Yes or no?
Yes, sir.
So from here you can see that in one revolution, the time it takes is t, the angle it turns is 2 pi, and the distance it moves is lambda. Do we understand this? Time taken is t,
Yes, sir.
distance moved is lambda, and angle turned is 2 pi. An angle of 2 pi is equal to, I can write it this way. An angle of 2 pi is equal to a length of or distance of lambda, that is equal to a time of t, capital T. Do we understand this? Do we understand what I've written here?
Yes, sir.
From here, I can convert angle into distances for a wave, or angle into time, or time into length, or length into angle. How do I do this? If I say delta phi is the difference in phase, delta phi by 2 pi will be equal to delta x by lambda, that will be equal to delta t by t. This becomes my formula to convert path difference into path difference, a phase difference into path difference, or phase difference into time difference, or time difference into phase difference, or time difference into part difference, or one difference into the other difference. Do you understand this?
Yes, sir.
This is the most important thing of this chapter. If you understand the meaning of phase difference and part difference, a large part of the life becomes very simple. Can I give you a question here?
Yes, sir.
Everyone noted this down?
Yes, sir.
So write this question. Question number 1. Two particles differ by a phase angle of pi by 3. Find delta x. What do you mean by delta x? Part difference. And delta t. What do you mean by delta
Path
t?
difference.
Find out the part difference and the time difference.
Time difference.
Your time starts now. 2 minutes you will get. Yes, bacha, shall I help you? Or you're trying? Taking so much of time. Shall I help you, beta? No one got the answer? Shall I help you? Please let me know. Are you trying, bacha? Yes, bacha. Shall I solve it?
Yes, sir.
You're not able to do it? Can you tell me what is the problem that you're facing so that I might help you? Okay, you're not saying anything. Okay, so I'll just put it in the formula that I have created. Delta phi divided by 2 pi is equal to delta x divided by lambda. Delta x divided by lambda. Now this phase difference delta phi is given as pi by 3, and I have to find out delta x from here. So I can create the formula for delta x. Delta x path difference will be lambda by 2 pi. Lambda goes here, multiplied by the path difference. So lambda by 2 pi multiplied by pi by 3. Pi se pi getting cancelled. The answer would be lambda by 3. Are you getting how I've done this?
Lambda by 6.
Oh, sorry, lambda by 6, not lambda by 3. Sorry. Did we get this answer? Yes or no?
Yes, sir.
Then why were you not telling me that you got the answer? Why did not you tell me, sir, we got the answer? Tell me, bacha. Everyone got this? What about the time difference? So I can again write delta phi by 2 pi is equal to delta t by capital T. So now I can write delta t time difference will be t divided by 2 pi multiplied by phase difference. How much is the phase
T
difference?
by 6.
Yes, the answer is t by 6. Why are you so scared, bacha? That is the correct answer, dear. Don't be scared. That is the correct answer. Do we get this? Yes or no? No, yes.
Yes, sir.
Can I give you one more question that can boost your confidence?
Sir.
Okay, here comes the next one, and I hope that I can get the answer straight away fast. 2 points differ by delta t. I hope you understand delta t equal to t by 2. Find delta x and delta phi. Let me see who gives me the answer first. Yes, my dear friends. Bacho, do I have an answer? Shall I do it?
Sir, doing.
Got the answer? Yes or no? No, yes. Shall I do it? Delta phi by 2 pi is equal to delta x by lambda is equal to delta t by t. Yes, my dear friends, do we have an answer? So from there I can write delta phi by 2 pi will be equal to delta t by t, or I can write delta phi will be 2 pi by t multiplied by the time difference. Time difference is t by 2, my dear friends. T cancel, this cancel. So the final answer that I will get, phase difference is pi. Do we understand this? Yes or no? No or yes? Did you
Yes,
get
sir.
the answer, beta? Why is it taking so long? Can you do the next one? Fatafat. I can use these two
Same,
now.
sir.
Yes, so from here I can write delta x by lambda will be equal to delta t by capital T. So my delta x path difference will be lambda by t into time difference t by t. So my delta x becomes lambda by 2. These are the two answers that we were hoping for. Everyone got this answer, yes or no?
Yes, sir.
Well then, that brings us to an end of this class. In this class, we have started with ray optics, with wave optics. We have seen what is wave. Continuous disturbance is a wave. We have seen the equation of a wave. We have seen displacement, amplitude, wavelength, angular frequency. We have also seen what is phase, and we have seen phase difference. In the next class, we will move ahead and go further deeper into the topic. So I'll meet you in the next class. Please be present there on time. Take care. Have a nice day. If you have any doubts, please come and ask me. Else, it's a right from my end. Bye, everyone. Enjoy.